Hi, welcome to Marker Board Videos. Today's video is about density. And density is simply a way of saying how crowded something is. So I want you to picture this. You have 50 people in a very small room. It feels very crowded. As opposed to 3 people in a small room, it doesn't feel quite so crowded. If you take those same 50 people and put them in a very large room, well, it doesn't feel crowded anymore. So density, how crowded something is based on 2 things. It's based on mass, or amount of matter, and it's based on volume. Because you can take something that seems really crowded in one room and make it seem uncrowded if you make a larger room. Or you can take something that's really crowded in one room and make it less crowded simply by removing some of the people. So there's 2 things that come into play when you talk about density: mass and volume. And mathematically, density is mass divided by volume. Remember, this line means divided by. For those of you who like magic triangles, density is mass divided by volume. And you know how to use a magic triangle, so I won't go into teaching you that. But if you need a magic triangle, there it is. Density is mass divided by volume. In water, actually, in any liquid, density determines floatability. So whether something's going to float or not is totally determined by something's density. Is it going to float? Is it going to sink? Let's specifically use water as an example. The density of water is about 1 gram per cubic centimeter, or 1 gram per cc, or 1 gram per milliliter. Centimeter, cubic centimeters, cc's, and milliliters are all exactly the same thing. Different ways of saying the same thing. So the density of water is about 1. If you have something with a density that's greater than 1, it's going to sink. If you have something with a density that's less than 1, it's going to float. So what do you think if you have something with a density of 1? That's right. Remember my magic word flink, which is a combination of sink and float? It's going to flink. Mass is pretty easy to determine. You just stick it on a balance, but volume can sometimes be problematic. So let's talk about 2 ways you can determine volume. The first thing is if you have a regular shape, like a cube or a cylinder or a sphere. We all know the mathematical formulas for determining that: length times width times height, that kind of thing. So you can do those mathematically. But what if you have an irregular shape like a rock and you haven't taken calculus, you don't know any of that kind of stuff yet? So how do you figure out the volume? Well, the way I learned it was by making peanut butter cookies for my dad. My dad loved peanut butter cookies, and I liked to bake, but I did not like making peanut butter cookies, because when you try to measure out a cup of that gloppy, sticky peanut butter in a measuring cup, it was always a mess. And one day I was making peanut butter cookies and a friend was over and she said, "You're doing that the hard way." And I'm like, "Okay, if you have a better way, show me." And what she did was she took a 2-cup measuring cup, filled it to 1 cup with water, and added scoops of peanut butter right into the water until the water level rose to 2 cups. At which point I had a cup of peanut butter and a cup of water. I dumped the water out, I had my peanut butter, it was good. That's called volume by displacement. Volume by displacement. You take a known volume of water, figure out what that volume is. If you're using a graduated cylinder, of course, you look at the meniscus, the bottom of the smile, if you will. Add your substance to it, add your irregular shape, and the water level will rise. Take that second water level and subtract the first from the second, and that will tell you exactly the volume of that object. If you don't believe me, go ahead and get a cylinder that you can measure the length and the width and the diameter, and you can calculate that mathematically. Then do it by displacement and you'll see I'm exactly right. It works 100% of the time, every time. Volume by displacement. Sometimes that's a quick and easy way of doing it. You have to be very, very accurate in your readings though, and your measurements. Be very accurate, be very, very careful with those. So those are 2 ways to determine volume. So let's do a couple of practice problems. Our favorite, word problems. An object has a mass of 6 grams and a volume of 3 cubic centimeters. What's its density? So here's my no wanton formula grid. I know the mass is 6 grams. I know the volume is 3 cubic centimeters. I'm looking for density, and I know density is equal to mass divided by volume. So density is mass, 6 grams, divided by volume, 3 cubic centimeters. 6 divided by 3 is 2. And my units are grams per cubic centimeter. 2 grams per cubic centimeter. Let's do one more practice problem. What is the mass of an object with a density of 2.5 grams per cubic centimeter and a volume of 10 milliliters? So I write my no wanton formula grid. I have 2.5 grams per cubic centimeter. Volume is 10 milliliters. I'm looking for mass. And I know whether I use my magic triangle or whatever I do, if I'm looking for mass, let's make sure you can see that. If I'm looking for mass, it's density times volume, okay? Mass is density times volume. The other thing I have to know is that 1 milliliter is 1 cubic centimeter, because I need my units to cancel out. If I'm left with mass, I want to be left with grams. And I need to make sure that I don't need to do any conversion there. But I know that 1 milliliter is 1 cubic centimeter. So I can simply say, instead of saying 10 milliliters, I can say 10 cubic centimeters. It's exactly the same thing. So here's my equation. Density, 2.5 grams per cubic centimeter, times volume, 10 milliliters. 2.5 times 10 is 25 grams. My cubic centimeters cancel out. I'm left with grams. That means I probably did it right because I have the right units. So there's your second practice problem.